Hi there. Now before I start part B of this question, just to recap if you didn't see part A, we had this curve. It was described by this equation here, x squared plus 4xy plus y squared plus 27 equals 0. And we were asked to find dy by dx in terms of x and y. And the answer to this was dy dx equaled the fraction minus all of x plus 2y divided by 2x plus y. Now we're told that a point Q lies on the curve, and the tangent to the curve at Q is parallel to the y-axis. Given that the x-coordinate of Q is negative, in part B now we've got to use your answer to part A to find the coordinates of Q, and this is for 7 marks. So if you'd like to have a go at this, I'll just give you a moment to pause the video, and when you come back I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Now, to appreciate this, when you've got a graph, let's just draw some axes here, x-axis, y-axis. We know that when you find dy by dx, it gives us the gradient to any point on a curve. So suppose I had a curve something like this, then we know that when we've got points like this up here, this type of point is a stationary point. We know that dy dx would equal 0. And that would mean in a fraction like this that the top of the fraction, x plus 2y, would equal 0. But in this example, we're looking at tangents that are parallel to the y-axis. So when we're looking for the gradient of this is undefined. And we get an undefined gradient when the denominator is 0. So that's where we start with this problem. We're going to set 2x plus y equal to 0 and then write, say, y in terms of x, substitute it into our equation of the curve to find out what the x-coordinate of Q is. And once we've got that, we can then substitute back in and figure out what y is. So, as I say, that's where we're going with this question. So, if we just write down the tangent is parallel to the y-axis when the denominator here is 0. In other words, 2x plus y equals 0. And if we rearrange this for y will equal minus 2x. And now we've just got to solve simultaneously our equations. That's this one with the equation of the curve. So if I call this equation 1 and this equation 2, then it's just a question of, say, substituting equation 2 into 1. So we'll just write that here, sub equation 2 into equation 1. So therefore, what we've got, if we put our value for y in the top equation then, is x squared plus 4x times y. Y is now minus 2x. Then we've got plus y squared, so it's going to be plus all of minus 2x, all squared. And then we've got plus 27, and that equals 0. So tidying this up gives us x squared minus 8x squared, and then plus 4x squared, and plus 27, and it equals 0. And grouping up our terms now gives us minus 3x squared, so therefore minus 3x squared. And if I subtract 27 from both sides, it equals minus 27. So if I divide through by minus 3, we end up with x squared equaling 9. And if we take the square root of 9, then it would normally be plus or minus 3. But we're told that x is a negative value. So therefore x must be equal to minus 3, since we'll just say x is less than 0. So if that's the case now, all I need to do to get y is, say, substitute x equals minus 3, say, into equation 2. And if we do that, we're going to therefore have y equals minus 2 times minus 3, giving us 6. And we're asked to find the coordinates of Q, so therefore Q has coordinates, the x coordinate being minus 3 and the y coordinate being 6.